Okay, if you're an AdonisJS developer, you're going to want to listen up. A really critical vulnerability has just been disclosed, and it could, quite literally, expose your applications to a complete server takeover. So let's break down exactly what this is, how it works, and what you need to do right now to keep your stuff safe. And when I say critical, I'm not exaggerating. I mean, look at this. A CVSS 4.0 score of 9.2 out of 10. Wow. A score that high tells you everything you need to know. It means this thing is easy to exploit from anywhere. It doesn't need a user to click on anything. And the impact, well, the impact is devastating for your server. So what are we actually talking about here? The official GitHub advisory puts it pretty plainly. An attacker can write any file they want to any location on your server's file system. Just let that sink in for a second. We're talking about the power to overwrite system files, configuration files, or even your application's own code. All right, let's put a name to this thing. The vulnerability is being tracked as CVE-2026-21440, and at its heart, it's a classic but incredibly dangerous type of flaw called path traversal. The scary part is where it was found, right in a core part of the framework. And here is the kicker. This vulnerability isn't hiding in some obscure optional library you might not even be using. Nope, it's in @AdonisJS/bodyparser. A fundamental package that practically every AdonisJS app uses to handle incoming data, especially file uploads. That means the potential attack surface here is just massive. Okay, so how does an attacker actually pull this off? Let's get into the technical nitty-gritty and see how they can basically break out of the box you've put them in and just wander around your file system. The best way to think about path traversal is with this mailroom analogy. So imagine your uploads folder is a secure mailroom. It's only supposed to accept packages addressed to that room. But this flaw lets an attacker scribble a new address on their package using special characters like ... to go up a level and target, say, the server room. The server, acting like a delivery person who doesn't check the address, just takes the malicious package and delivers it right there. So where's the weak link in the code? It all boils down to one function, MultipartFile.move. See, when a developer calls this function but forgets to include a specific security options argument, the code just defaults to trusting whatever file name the user provides. It doesn't clean it, it doesn't check it, it just uses it. And that's the open door. So you can picture the attack playing out in 4 super simple steps. First, the attacker creates a file with a malicious name, using those ... sequences. Second, they upload it through any normal file upload form on your site. Third, your backend code, if it's not written carefully, calls that vulnerable move function. And finally, boom, the file gets written to a sensitive location, maybe overwriting a critical config file. Now, being able to write a file anywhere is bad for sure, but the real nightmare is what that leads to. Let's talk about how this one simple flaw can escalate into a complete server compromise. This visual really says it all. On the left, you've got what's supposed to happen. A safe image lands right in the uploads folder. No big deal. But on the right, using the exact same function call, an attacker can trick the system into putting their malicious files somewhere dangerous, like a startup script that runs every time the server boots up. And that brings us to the big, scary question, right? Once an attacker has the power to change the very code that your server executes, what can't they do? The answer, of course, is remote code execution, or RCE. By overwriting an executable file or a script, the attacker can inject their own code. The next time the server runs that file, the attacker's code runs too, with all the same permissions as your application. At that point, they basically own your server. They have complete control. Okay, that was a lot of doom and gloom. We've seen the problem, we've seen the catastrophic potential. So now, let's get to the most important part, what you can do about it. Let's walk through the steps to fix this. And listen, there is absolutely no time to waste on this. Just look at how quickly this all went down. The vulnerability gets published on January 2nd. By the 5th, a working proof of concept is already out there on GitHub. And by the 6th, public exploits are circulating. The window to patch is closing fast. All right, here's the immediate fix. I want you to go check your package.json file right now. If you see @AdonisJS/bodyparser version 10.1.1 or anything older, you need to update to version 10.1.2 immediately. And if you're on the bleeding edge, the pre-release track, you have to get to version 11.0.0-next.6. This is the single most important thing you can do.
Now, beyond just updating, it's always smart to have a defense-in-depth strategy. So priority number 1, update the package. But If for some reason you absolutely can't, you must start sanitizing and validating every single file name that comes from a user. On top of that, lock down your file system's permissions so your app has the least amount of privilege it needs to run. And finally, keep an eye on your logs for any weird-looking file upload attempts.
So you go and patch this one flaw, your app is safe from this specific exploit. That's great. But this whole thing, this critical bug hiding in plain sight in a core package, it forces us to ask a much bigger question, doesn't it? What else is lurking in that massive node modules folder of yours? Is your software supply chain really as secure as you think it is? That's the question every single one of us should be asking ourselves today.